going to take a few moments now and look at percent by mass within a compound. This is very easy to do if you know the chemical formula, but if you don't know the chemical formula, you have to look at the data that came out of the lab. For example, if we have a compound known as iron 3 hydroxide, it's made of 3 different elements, but it's got more than 3 atoms. In the formula, I've got 3 oxygens and 3 hydrogen and 1 iron. Now, if I look at a sample of iron 3 hydroxide, let's take a sample of 106.87 grams. Let's look at what the different associated elements have actually contributed to that. From this example, iron would have brought in 55.84 grams. The oxygen would have brought in 48.00 grams. And the hydrogen, 3.03 grams. Now, I think you can see that if I add all those together, I end up with the 106.87 grams of the total compound. Now, if I want to calculate the mass percent of any one of those in there, you have to remember what percent is. You'll recall that percent is parts of the total. And if I remember that the percent is parts divided by the total, then you have to shift your decimal by multiplying by 100, as we've standardly done. Then we have to look at that and say, okay, then if that's the case, I can calculate the mass of iron in its percent by taking 55.84 divided by 106.87. That'll give me the mass percent of iron. If I do the same thing with the oxygen, and then I come back and do the same thing with the hydrogen. That's going to give me the 3 different percents that I need, and when I get done, I should be able to add them up, and they're going to get 100%, theoretically. So I'm going to get my calculator and try that. Okay, now I finished the math. So I've got 52.3% iron, I've got 44.9% oxygen, and 2.8% hydrogen involved in there. So any place I find this compound in the universe, it would always have those fixed proportions. This is an example of law of definite proportions. Now, from that then, I'm going to go ahead and add them together and see if they truly add up to 100%. In this case, they add up mathematically to exactly 100%. So I know that I've done my calculation right. All right, well, if that's the case with iron 3 hydroxide, let's extend that a little bit to calcium chloride and try that one as well. Okay, I've got my calculations on the board then. If I look from the periodic table, I can do exactly the same thing I did in my last example. My formula is calcium chloride with CaCl2. So it has 1 calcium and it has 2 chlorines. If you look up the atomic mass on the periodic table, calcium has a mass of 40.1 atomic mass units. And I have 1 of them in my formula for a contribution of 40.1. Chlorine has a mass of 35.5 atomic mass units on the periodic table. There are 2 of them in my formula for a contribution of 71.0. If I sum those 2 together, I get 111.1 atomic mass units for that formula. So now if I want to calculate my mass percent involved in those, since an atomic mass unit is an example of a mass, we're going to go ahead and take 40.1 AMU divided by 111.1 AMU, and we're going to get the percent calcium. We'll do the same thing, 71.0 AMU divided by 111.1 AMU, and we'll get the percent for the chlorine as well. So let's go ahead and plug those in our calculator. Okay, now I've gone ahead and calculated the percents. If I add those together, they do come up with exactly 100%. Now, sometimes you're going to calculate these and they're not going to come up with exactly 100%. They'll come up with 99.9% or some number that's very close. In that case, it's just because of the way we've grabbed our significant figures from the periodic table. But in this example, we ended up 36.1% calcium. We end up with 63.9% chlorine. They are at fixed ratios by mass, always. This is an example then of the law of definite proportion.